Let's consider what happens if we try to graph y equals quantity x minus 2 times a quantity x plus 3. What can we determine about this graph? Now, the usual way that people learn to graph things is plugging numbers in for x and finding the values of y, making a table, and graphing a bunch of points to get the trend of the graph. We're not going to do that. We're going to use more sophisticated ideas. So, in order to graph this, you ought to, of course, pause at this particular moment and see if there's anything you can do to figure out some points on this graph without actually plugging in a lot of x values. But hopefully you've done that, but maybe you don't even know what I'm talking about, so I'm going to illuminate this a little bit. Okay. First of all, the two questions we always want to ask when we're trying to graph an expression is, what are the x and y intercepts? Now again, that's a term you might not be completely familiar with, so I'm going to define it in a minute. Well, I'm going to tell you right now, the x-intercepts are the points at which the graph of this expression would lie on the x-axis, and the y-intercepts are the points at which the graph would be on the y-axis. And the x-intercepts, well, a point on the x-axis, a point is going to be on the x-axis if y is 0, because the x-axis is a set of points where the y-coordinate is 0. If the y-coordinate is more than 0, then you're on a horizontal line above the x-axis. If the y-coordinate is negative, you're on a line below the x-axis, but right in the middle, the perfect spot, you're on the x-axis, and that occurs when y equals 0. The y-coordinate is 0. So what are the x and the y-intercepts of this graph? See if you can figure that out while I write a couple of things down here. So an x-intercept are points x, y that satisfy this relationship. They're the points on the x-axis that satisfy this relationship, and they occur when y equals 0, because the x-axis is where y equals 0. And the y-intercept is the points that satisfy this equation, the x and y coordinates that satisfy this equation when x equals 0. It's the points on the y-axis. Points on the y-axis occur when x equals 0. Okay, well, so if x equals 0, start with that one, what's the value of y? You should have answered that. If you haven't, pause and think about it, but it's pretty obvious. Y equals 0 minus 2 times 0 plus 3, which is negative 6. Telling us that the point 0, negative 6 is on the graph of this equation. So right here we've got the point, and we'll call that point 0, negative 6. That's the y-intercept. Okay, now if y equals 0, what's x? Now there might be more than one answer to this or to this. Now there's only one answer here. You plug in x equals 0 and you get what you get. But if y equals 0, what? Can you give me a value of x that makes y 0? Well, okay. X equals 2, because if x equals 2, you have 2 minus 2 multiplied by x plus 3. That's going to be 0 multiplied by whatever x plus 3 is. Of course, that's going to be 5 if x equals 2, but that doesn't matter. As soon as this is 0, you know the whole thing is 0. Also, x could equal negative 3. If x is negative 3, then you're going to have 0 here, and multiplied by this, doesn't matter what this is, you're going to get y equals 0. Now, the other thing is, this is so, I'll say, and it's so for no other value of x. Why is it so for no other value of x? Well, any value other than 2 or negative 3 is going to make both of these numbers, well, neither one of them is going to be 0. If x isn't 2, then this isn't 0. If x isn't negative 3, this isn't 0. So if x isn't one of these values, neither one of these is going to be 0. And when you multiply together two numbers that aren't 0, you don't get 0. So the full statement would be, for no other value of x other than 2 or negative 3, since any other value of x would yield two non-zero numbers whose product can therefore not be 0. If the two numbers are non-zero, their product can't be 0. Now, on the graph, I'm going to indicate that simply by saying, well, okay, y is 0 when x is 2, which is going to give us the point 0, 2 on the graph. So here's our point 0, 2. And y is 0 when x is negative 3, so we also have the point 0, negative 3 on the graph. Okay, now based on those 3 points, we really can't draw the graph. We don't know what it's going to look like. This point isn't exactly halfway between these, so we're not sure. Do we come down here, down below this point, and then come up through it and make the graph nice and symmetric? Or do we come down through here and kind of wobble over to here and then come up through here? And, you know, what is the graph going to look like? Well, that's what we're going to address next.